Our planet, Earth, makes a fascinating journey around the sun every year. Contrary to what many people think, this journey is not a perfect circle. Instead, the Earth's orbit is elliptical, resembling an elongated circle. This elliptical orbit leads to fascinating phenomena, one of which is aphelion, the point at which the Earth is at its farthest distance from the sun. This year, aphelion occurs on Friday at 1:06 a.m. Eastern Time. Let's take a deep dive into this annual celestial event and uncover its significance and impact on our planet. To understand aphelion, we must first explore the nature of Earth's orbit. The path that the Earth follows around the sun is not a perfect circle, but an ellipse. This means that there are points in Earth's orbit where it is closer to the sun, known as perihelion, and points where it is farther away, known as aphelion. The elliptical shape of the Earth's orbit is due to the gravitational forces exerted by other planets in the solar system. These gravitational interactions pull and tug at Earth's orbit, causing it to elongate slightly. Kirby Runyon, a geologist at the Planetary Science Institute, explains that all the planets in our solar system move in these elongated orbits around the sun. This is not only true for our solar system, but probably for planetary systems around other stars as well. The culprit behind these elliptical orbits is gravity. The planets exert gravitational forces on each other, constantly pulling their orbits away from perfect circles. The result is a chaotic yet beautifully orchestrated cosmic dance. Jupiter, the most massive planet in our solar system, has the greatest influence on the orbits of other planets due to its powerful gravitational pull. The influence of this giant planet is a major factor in maintaining the elliptical shape of our orbits. But how do we measure how much an orbit deviates from a perfect circle? This is done through a concept called eccentricity. Eccentricity measures the deviation of an orbit from a perfect circle. The higher the eccentricity, the more elliptical the orbit. Let's look at some examples to understand this better. Mars, with an eccentricity of 0.094, has an orbit that varies significantly in distance from the Sun, ranging from 129 million miles to 155 million miles. This variation results in significant changes in the amount of sunlight Mars receives during its orbit. Pluto, which has an even higher eccentricity of 0.244, varies from 2.8 billion miles to 4.5 billion miles from the Sun during its orbit. This extreme variation causes dramatic changes in sunlight and temperature on Pluto. In contrast, the Earth's orbit has a relatively small eccentricity of only 0.017. This means that our planet's orbit is nearly circular. Larry Wasserman, an astronomer at the Lowell Observatory, notes that if you drew the Earth's orbit to scale on a piece of paper, you wouldn't even notice that it was slightly flattened. This nearly circular orbit results in less dramatic changes in distance from the Sun compared to planets like Mars and Pluto. So how far away from the Sun will we be at aphelion? At this point, the Earth is about 94.5 million miles from the Sun. By comparison, 6 months later, at perihelion, the Earth is at its closest point to the Sun, about 91.5 million miles. This 3 million mile difference may seem huge from our perspective on the ground, but it is relatively small on astronomical scales. The size of the Sun in the sky appears about 4% smaller at aphelion than at perihelion, but this change is so small that it's difficult to notice without precise instruments. Now, you may be wondering if this change in distance from the Sun affects temperatures on Earth. Interestingly, the answer is yes, but not in the way you might think. A common misconception is that the Earth's varying distance from the Sun is what causes the seasons. While it has a small effect, the primary factor that causes our seasons is the tilt of the Earth on its axis. This axial tilt means that at different points in Earth's orbit, the hemispheres are tilted either toward or away from the Sun, resulting in the seasonal changes we experience. At aphelion, which occurs just a few weeks after the summer solstice in the northern hemisphere, the northern half of the planet is tilted toward the Sun. This results in the longer, warmer days of summer, even though the Earth is at its farthest distance from the Sun. Conversely, at perihelion in January, the northern hemisphere is tilted away from the Sun, resulting in the shorter, colder days of winter. In the southern hemisphere, the pattern is reversed. During aphelion, the southern hemisphere tilts away from the sun, resulting in cooler winters. When the Earth reaches perihelion, the southern hemisphere tilts toward the sun, resulting in warmer summers. This interplay of axial tilt and elliptical orbit produces the seasonal variations we observe. For planets with more pronounced eccentricities, the effect of varying distance from the sun can be much more significant. For example, sunlight on Mars can vary by as much as 31% along its orbit due to its higher eccentricity. This significant change in sunlight leads to more extreme seasonal variations on Mars compared to Earth. It's also worth noting that the timing of aphelion and perihelion relative to the solstices is a coincidence that will change over time. The gravitational influences of other planets continue to alter Earth's orbit slightly, so that its eccentricity is currently decreasing. This gradual shift toward a more circular orbit will continue, subtly altering the timing of these events. Imagine for a moment what would happen if there were no aphelion. If the Earth's orbit were a perfect circle, the lengths of the seasons would be exactly the same. Currently, spring and summer are slightly longer than fall, and winter in the northern hemisphere because of our elliptical orbit. A perfectly circular orbit would equalize these seasonal lengths, but not much else would change significantly. Dr. Runyon suggests that if we could magically make Earth's orbit perfectly circular, we would probably not notice much difference in our daily lives. However, if something were to increase the eccentricity of the Earth's orbit, the consequences could be dramatic. A more eccentric orbit would lead to more extreme seasonal variations, especially in the southern hemisphere. Summers could become unbearably hot and winters could become unbearably cold, with potentially severe impacts on agriculture and human civilization. Crop failures and extreme weather conditions could become more common, posing significant challenges to the sustainability of advanced societies. Fortunately, our planet is currently in a relatively stable and favorable position within the solar system. The slight eccentricity of our orbit, combined with the axial tilt, creates a balance that allows for the diverse and life-sustaining climates we experience. This delicate balance highlights the intricate and interconnected nature of celestial mechanics and its impact on life on Earth. As we continue to study and understand these cosmic phenomena, it's important to appreciate the complex and dynamic interactions that shape our planet's journey through space. The annual event of aphelion is just one piece of this grand puzzle, reminding us of the beauty and intricacy of the universe we inhabit. So the next time you enjoy a warm summer day or gaze up at the night sky, take a moment to reflect on the incredible celestial mechanics at play. Our planet's orbit, the gravitational influences of other celestial bodies, and the ever-changing dance of the cosmos all contribute to the world we know and love. And as we learn more about these phenomena, we continue to uncover the wonders of our universe and our place within it. What do you think about the Earth's elliptical orbit and the phenomena of aphelion and perihelion? Have you noticed the subtle changes in the size of the sun or the length of the seasons? Share your insights and questions in the comments below. And if you're curious about other celestial events or have topics you'd like us to explore, let us know. Together, let's keep the spirit of discovery alive and continue to marvel at the wonders of the cosmos.